Alright, ladies and gents, this is Wharton again, Algebra 2, move up. We're going to work on 4-1 graph and quadratic functions today. This is the last unit in the first semester, so you are probably, hopefully finishing up in the last unit 3. You're getting into this unit 4, and you can finish this up by finals, and then you'll be very successful in the class. This is probably one of the harder units. This is mostly Algebra 2 material. So we got to make sure we get this. First units were kind of a breeze. This one, if you're not strong in math or you aren't really putting up much effort in, you can definitely tell on this unit. So please make sure you put in a little more effort maybe, and continue, and then we'll end up passing and be good to go. Now I'll take the class over again. That'd be great, huh? So again, it's a Algebra 2 skill. We're going to graph quadratic functions using tables, graphs, stuff like that, in vertex form, standard form, stuff like that. Okay? So a quadratic function is y equals, the very basic form of a quadratic function is y equals x squared. Okay, that's a quadratic. What it does is it looks like a U. So it looks like a U, upside down or right side up U. Okay, it's what's called a parabola. All right. The axis of symmetry, this is going to be important. So here, here, and here are going to be important for us. Okay. The axis of symmetry is, in order to find this, is going to be x equals negative a. I'm kidding, not negative a. What am I talking about? X is equal to negative b over 2a. Okay, negative b over 2a. And the vertex, so I'm going to bring it over here. The vertex is an ordered pair, x comma y. Well, x is negative b over 2a, comma, whatever the y value is. So we have to plug the negative b over 2a back into the equation, and then we'll be able to get the y value of the vertex. In standard form is what we call ax squared plus bx plus c is equal to y, or y equals over here. It doesn't really matter where the y goes, but standard form is what looks like this, meaning there's no parentheses, it's just an x squared term, an x term, and a regular number, and it could be missing the bx plus c part, but it's still quadratic. It needs the power of 2 in order to be a quadratic. If it doesn't have that, then it's not. So please make sure that's important. But let's kind of move on to the first 4 examples here. Not too difficult, actually. Well, it could be, I guess. I don't know, depending upon your level of enthusiasm. But what I want to do is, because this is in standard form, right, ax squared plus bx plus c, same thing here, same thing here. This one's a little weird, but I can rewrite this as x squared minus 4x plus 2. So now that's in standard form. All right, so we're all in standard form, so we're good there. What I now want to do is I want to graph the function. So there are some rules and some steps to follow. The first one that you want to use, the first step is find the axis of symmetry. I'm going to abbreviate this as AOS from now on, because it's just easier to write AOS instead of saying axis of symmetry every time. And how you do that is you take x is equal to negative b over 2a. Now this negative of b, it's really the opposite. Yes, it's a negative sign, but it means the opposite of whatever b is. So let's write down what a is. A is 3, b is negative 12, and c is 6. So let's find out what this is. X is equal to the negative of b. Well, b is already negative, so now it's positive, right? We flip the sign of whatever b is. 2a, 2 times a. A is 3, 2 times 3 is 6. And I get 2. 12 divided by 6 is 2. What does this mean? The axis of symmetry means that my graph, okay, is going to look like a U. Okay? And the axis of symmetry is going to be a vertical line that cuts the graph in half. I'm a rhymer like Dr. Seuss, graph in half, right? And so that's a dotted line. So I'm just going to draw the dotted line. So at x equals 2, x is 2 right here. So I'm going to draw a dotted line down there to show you that the graph is going to be like in half. Like if I did one side, I could fold it over that line and get the same answers on the other side. All right? So that's the first step. Find the AOS. Step 2. Find the vertex. Remember, we find the vertex by plugging in the AOS into the original equation. So the AOS was 2, so I'm going to take the 2, I'm going to take the 2, plug it in, find out what I get. Plus 6. So this is 4 times 3 is 12, minus 24 plus 6, so negative 12 plus 6 is negative 6. So that means my vertex is going to be 2 comma negative 6. The AOS splits the graph in half, right? We talked about that. But also, that's where the vertex is going to be on. So the vertex is kind of the lowest point on the U or the highest point on the U, okay? And that's where the graph really starts from. So on the AOS, there's going to be the point there, which is whatever the vertex is. So 2 comma negative 6 is going to be down here. 2 comma negative 6. Okay? Then your step 3, and this is really the final step, is you're going to use the pattern of 1, 3, 5. What does that mean? That means I'm going to make a table that has 1, 3, 5 in it. And I'm going to multiply by whatever A is. So multiply by A. Well, what's A? A is 3, right? We already had that down. 1 times 3 is 3. 3 times 3 is 9. 5 times 3 is 15. Then these are the numbers that we're going to use to graph the U. Alright? Here's how I do it. I go to the dot that I graphed, my vertex. I'm going to use the first 3. I'm going to go up 3. 1, 2, 3 over 1. I'm going to do the same on the other side. Up 3 over 1 over here. From the dot that I now just graphed, I'm going to go up 9 and over 1. I always go over 1 because this is underneath 1, right? 9 over 1. Up 9 over 1, like slope. So up 9 over 1. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. And I'm going to do the same thing over here. So you can see how the line is now cutting the graph in half. You can see the 1, 3, 5 rules. Well, this is 15, and 15, if I go up again, is off the graph, so I'm done. Now I'm going to connect the dots, like in first grade. This bottom is always going to be like a U. It's never going to be a V. It's never going to come there. It's going to always be like a rounded bottom. That sounded weird. And then I'm going to go through my dots, and I'm going to go up. Again, these don't have to be accurate, but you at least have to have the dots there, okay, so I can look at what I'm seeing. And there's your graph. That's it. This is a very skinny one because A is big. If A was small, then it would be pretty flat, like I sat on it, right? So those are your steps. Let's do the second one, h of x here, and then you'll do the next 2. So because this is already in a standard form, I'm going to say A is -2, B is 8, C is -3. We don't really need C, do we? Not really. The first step is I'm going to find the AOS. So x is equal to -b. The opposite of b is -8 over 2 times -2, which is -8 over -4, which is +2 again. Okay? So I'm going to put a dot on 2, or a line on 2. Great. I'm now going to find the vertex, remember, by plugging in AOS. So I get -2 times 2 squared plus 8 times 2 minus 3. This is 4 times that is -8 plus 16 minus 3. -8 plus 16 is 8. 8 minus 3 is 5. So my ordered pair of my vertex is 2, 5. 2, 5 right there. Great. Number 2, I want to the third step, I'm going to find your 1, 3, 5 rules. So I got 1, 3, 5 multiplied by the A value, which is, we'll make A 2, okay? Instead of making -2, we'll just multiply by the positive values all the time. That's not a big deal. So 1 times 2 is 2, and then 6, and then 10. So these are my new numbers. Here's what you got to understand. If A is positive, A is bigger than 0, the graph looks like this. If A is less than 0, the graph is upside down. So this graph is upside down because it's negative. So instead of going up 2 and over 1, I'm going to go down 2 and over 1 in both directions. Then from that dot, I'm going to go down 6. 1, 2, 3, 4, 5, 6, and over 1. In the same way in the other direction. If I could fit 10 on my graph, then I would do it. But I can only fit, it looks like, another 5. So my 10 would be like down here somewhere, and I don't really want that. Now I just draw my graph. Remember, it's got to look like a U or some rounded bottom, never to a point. That's absolute value. Okay, it's really hard to draw on these with what I'm using here. But there you go. That's your graph for the second one there. All right, I want you guys to do the second one, pause the video, or the second and third, I'm sorry, the last two. Oh man, this is going to be a long day. The last two, pause the video, and then hit play.
I'm Michael Scott. That should say world's best teacher. Pause the video.
All right, this one here, AOS, boom. I'm going to skip some steps here, so hopefully we understand how to do AOS. Remember, it's the opposite of B over 2A, so it's negative 10, so I get negative 1. So my AOS is going to be a dotted line at negative 1. The dotted line is not necessary, so if you don't draw it, that's okay. If you need to draw it to show you where the half of the, where it splits the graph, that's fine too. As long as you draw a dotted line, not a regular solid line, then we'll be okay. Let's plug that in. I get negative 5 times negative 1 squared minus 10 times negative 1 plus 6. This is 1 times that is negative 5. This is plus 10 plus 6. So that is that right? I think so. I think that looks right. So that's negative 5. That's 5. That's 11. Okay, so my graph is going to be off by a little bit. So 9, 10, 11. That stinks. I'm sorry. I didn't want it to be that high. That's my fault. All right. Now let's do our 1, 3, 5. So that's step 3. So 1, 3, 5. Because A is 5, I'm going to multiply by 5. So I get 5, 15, 25. So let's go down 5. Well, if I go down, this is 11, so 10, 9, 8, that's 3. 4, 5, and over 1. 4, 5, and over 1. Now let's go down 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Again, I'm off the graph a little bit, but that's okay. And then we'll be over here. So you can see that this graph is very, 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 very skinny. Much like I used to be. I'm just kidding. Maybe when I was like born. Oh, this should be over here. Sorry. That dot should be over there. Oh man, that dot should be way over there. My fault. I drew that wrong, but you see the point. Okay, that it's basically very skinny that way. All right, let's do the last one. Remember, this was x squared minus 4x plus 2, where a is 1, b is negative 4, and c is 2. So I get step 1. I get 4 over 2, which is 2. Another 2, 1. B, you plug in 2. You get 2 squared minus 4 times 2 plus 2. 4 minus 8 plus 2 is negative 2. So 2 comma negative 2 is the vertex. Our 1, 3, 5 rules. Well, since a is 1, boom, then this is going to be the same. That's going to be the same. So let's go up 1 over 1, up 1 over 1, and then up 3 from here. 1, 2, 3, and over 1, and then the same. And then up 5 and over 1. 1, 2, 3, 4, 5, and over 1, and then the same over here. So you can see that my graph now is a little bit kind of wider because a is 1 and not 5 or 2 or 3. All right, great. All right, welcome back. This is example type number 2, and we're going to basically doing the same thing. We're not really going to graph them, but we're going to be talking about min-maxes and domain and range. And we'll talk about kind of what those mean in definitions and have those down. It's not a very hard concept. Minimum is what we call the lowest point on the graph. So that means the maximum is probably the highest point, right? Pretty simple on a graph. For domain, it's the x values, and for the range, it's the y values. Now, when I say x values and y values, it's the x values and y values that I'm able to get out of the function You can't just be like, oh, it's -3. Well, it might not even exist at -3, so we got to do some math to figure that out. Okay? All right. So let's scroll down. So to find the minimum and maximum values, we're going to do that first. We're going to find minimum and maximum values. Basically, if I think about the graph, any graph on parabola, it could look like this or like this. If this is the lowest point right here, that's the minimum. And if this is the highest point right here, that's the maximum. Well, what do we call each of these points? That's what we call the vertex. So what I'm going to do is we're actually going to just find the vertex here. Okay? And the minimum and maximum values, all it wants is the y value. So what is the min-max value? Boom, you're going to find the y value of the vertex. That's all we're going to be doing. Okay? So remember, the first thing I got to do is find the AOS, very similar to what we did on the first example type. So I get -12 over -4 times 2, which is -12 over -8, which is -3 over 2. A positive 3 over 2. Sorry. Then I plug it in, and I get -4 times 3/2 squared plus 12 times 3/2 plus 18. 3/2 squared is 9/4 plus 12 times 3/2 is 18 plus 18. Okay. And then 9/4 times -4 is -9 plus 18 plus 18. So that's going to be 27. So this is the min or max. How do I determine that? Well, this -4 tells me the graph goes which way? The graph goes upside down because it's negative. So if it's upside down, that means the highest point is up here. That means this is a maximum value. So the 27 is a maximum value. If it asked you for the AOS or the axis of symmetry, then it would be just 3/2. Okay? Alright, so that's min-max values. Let's do domain range. So we got to understand some things. This is a quadratic. It's a quadratic. All of these are all quadratic, right? Because they have a power of 2. A quadratic is also what we call a polynomial function. Polynomial function. And polynomial functions are continuous everywhere on X. What does that mean? That means that my graph, if I draw my graph this way, or if I draw my graph this way, the more I zoom out of that graph, this X is really going to keep going, and this one here is going to keep going, so that all of my X's are going to be touched. Now, it's going to take a long while maybe to get to like -1,000,000, but it's eventually going to touch it. And so that's why it's continuous everywhere. So on a polynomial function, the domain is always all real numbers. All real numbers. Okay? The range uses the y value of the vertex. So remember, the vertex here was 3, 2, 27. This graph, did it go up or down? Because A is negative, it went down, right? So it's actually like this. So this 27 is going to factor into my range like this. Because 27 is the biggest number, it's going to go from -infinity to 27. Okay, so it goes from, these arrows keep going down and 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 down. Same thing here, down and down and down and down and down. So -infinity, it comes up from -infinity, and then it reaches 27, and it doesn't go any higher. And this is what we call interval notation. 27 is included in the graph. Like the graph actually touches 27, so it's included. So we need square brackets. Whenever we have infinities or negative infinities, we always use parentheses. Okay, we always use parentheses. And that is the range. Or you can say this. y is less than or equal to 27. That's another way you can write it. That's okay. It means it stops at 27, but it could be any number less than it, like negative a million, or negative 3 million, or negative 15 quadrillion, or whatever. It could be anything less than 27, but it cannot be like 28 or 29. Okay? There's two ways to write it. I'll accept both of those if you want. Let's go to the next one. Min-max. Remember, the first thing I got to do is find the AOS. So it's 24 over 4 times 2. So 24 over 8. So 3 is the AOS. We got to plug it in. 4 times 3 squared minus 24 times 3 plus 11. 9 times 4 is 36. 36 minus 72. Sorry, 36 minus 72 plus 11. Negative 36 plus 11 is negative 25. So this is the min or max. What's happening to the graph? The graph is looking like this because A is positive. So that means negative 25 is going to be down here, and it's a minimum value. Okay? Our domain is all real numbers, because it's always going to be all real numbers for quadratic. Okay, our range, negative 25 is now the smallest, so it goes up. So you can write it as y is greater than or equal to 25, negative 25, I'm sorry. Or you can say negative 25 to infinity. Remember, parentheses on that, closed brackets on that negative 25. All right, I want you guys to pause the video, work on the next two, and then hit play.
I'm Warren Buffett. I'm the third richest person in the world, and I still eat at McDonald's every morning for breakfast. Pause the video.
All right, the answers for the last two problems are there. The AOS in the first one is 1. Once I plug the 1 in, I get positive 4. So that's the maximum value because the graph is upside down. Okay. The domain, again, is all real numbers, and then the range is from negative infinity to 4. So it goes down, so that means it comes up from negative infinity, hits 4, and never goes past it. Next one, it's for fractions, so you got to understand it probably takes a little longer to do that, but that's okay. The AOS is going to be negative 10 thirds once you do the math. You plug negative 10 thirds in, and you're end up going to get negative 28, which is a maximum value because, again, the graph is upside down. Actually, that's not a good graph for this one. Let's do, there we go. Because it's negative 28, that's below the x-axis. So then the domain, again, is all real numbers. My range is negative infinity to negative 28, closed on the 28, open on the negative infinity, or parentheses, square. Okay, parentheses, and then square bracket. This is the last example in this section. I probably didn't need to even put this in here, but I think it's valid and it's important, so that's why I added it in here. There will be some stuff in here that I skip based on just not needing it. If you're taking pre-calculus next year, you probably will see this more so, especially this equation here, something like that. But for Algebra 2, I'm not going to use some of those variables, okay? So we're going to graph a quadratic equation in vertex form. Vertex form, this is what it looks like, with numbers filled in, obviously not H and K's and A's and B's. The A is basically our, if you want to consider it our slope, like I'm going to put it in like in parentheses, or not parentheses, those are quotations. Because it's not really slope, but it kind of acts like a slope. It is what we call our amplitude. We amplify the value. So if it's here and here and we're amplifying it, then this value is going to stay, but we're going to take this value and move it up and then keep moving it up. And that's how we're amplifying stuff. The B value, I shouldn't have wrote it. It's more for pre-calc. You guys don't need it for what we're doing today. H is the X value of the vertex. And then K is the Y value of the vertex. Now, you'll see that it says negative H right here, minus H, and this is H. So really, what happens is we flip the sign for X value. Okay? Flip the sign. What's nice about vertex form is we don't actually have to find the AOS. We don't have to find the vertex by plugging a number back in. It automatically tells us what the vertex is just by looking at the equation. So that's why these are a lot easier. That's why I figured I'd put them in there, right? Because it's pretty easy. So let's find the vertex. The vertex is the number here, just flipped, 2, comma, and then the exact number out here. So this is the H. and this is our k. So the h is flipped, the k stays. H is flipped, k stays. H is flipped, k stays. Let's graph it. 2, -2. 2, -2. The a value is negative, right? It's that 1 right where that negative is right there. So a is less than 0, so it goes down. But a is 1, or -1 really, but it's 1, that's fine. So we're still going to use our 1, 3, 5 rules that we talked about, but I multiply by 1. So these stay the same, right? 1, 3, 5. Because I go down 1 over 1 in both directions. From the new dot, down 3. 1, 2, 3, and over 1. Down 3 and over 1. Down 5 is off the graph, so I'm done. And we are done. That's it. That's all we got to do. This next one, what's the vertex? Flip the number inside. Same number outside, 3. So -2, 3 is our vertex. This opens up because a is positive. So a is equal to 3. So our 1, 3, 5 rules become 3, 9, 15. So let's go up 3, 1, 2, 3 over 1, over 1. And I can't go up any further, so I am done. That's terrible. Let's try to fix that. That's a little bit better, but not much. Okay, and that one's done. I think there's 2 more for you to do. There is. Go ahead and try those 2 and see what happens. Pause video and hit play. So my 1, 3, 5 changes to 2, 6, 10. I'm going down because a is negative. And so I go down 2 over 1, 2 over 1, and then 6. But I don't think I can get to 6, so it's going to be like off the graph by 1 number. So we can kind of do that if you want to. And, oof, man, my tablet that I'm drawing on is not very good, apparently, to make these lines. Okay, the last one, and the vertex is 3, 4. So 3, 4 is up here. It's going to go down because a is negative. So 1, 3, 5 become negative, or become 4, 12, 20. So I'm going to guess 4 is the only one that we're going to be able to fit on there. So 1, 2, 3, 4 over 1 over 1. Yeah, 12 is going to be like way down here somewhere. So I guess you can graph that if you want to, but that's basically what's going to happen. It's going to be very, very skinny. Alright, that concludes, I guess, this section, 4.1, and I will see you in the next one. I think it's 4.2. Deuces.